Okay guys, so today we are officially done with trig. We are moving into the math analysis part of the course. We're going to start with something that you guys should be pretty familiar with, and that is solving systems of equations. Just as a refresher for you, there are different types of systems of equations. We are going to be looking specifically at linear equations. When you are solving for systems of equations, you're looking for the places where the two equations are equal. So if you look at this first one, there are two lines that intersect in exactly one point. So this coordinate is the solution, and there's only one solution. Because we're looking for the place where the equations are the same, or the lines are the same, you should notice that parallel lines never touch, so there are no solutions. And then sometimes you have two lines that overlap each other. And in this case, we have infinitely many solutions. Today we're going to look at three different methods of solving a system of equations. The first is the substitution method. And with substitution, you're going to solve one of your equations for a specific variable. In this case, I'm going to solve the second equation for x. And the reason is because all I had to do was add 2y to both sides, and x was already isolated. I don't necessarily recommend substitution if you can't do something like this very simply. Once we've done that, all of this that x is equal to goes in place of x in the other equation. So I now have 4 times all that stuff that is x, 2y plus 1, and I recommend you always put that in parentheses, minus 3y equals 14. Here I just distributed 4 times 2y, 4 times 1. Now I combine like terms, and then I solve for y. You are not done here. You still need to solve for x. So I now take this and I put it way back up here so that I can find out what x is. So the solution to this system is the point 11, 5. The elimination method, otherwise known as linear combinations, is one that not a lot of students like until they start to recognize that sometimes it really is the easiest method. And the purpose of the elimination method is to add your two equations together so that you can eliminate one of the variables. So I always tell people, before you do anything else, mentally add your equations together. Did anything get eliminated? In this case, nothing got eliminated, so we have to do something before we can just add them together. The thing that you'll do is you'll multiply either one equation or both equations by any number. It doesn't even matter the number. But you want to pick your number specifically so that when you add them together, something will be eliminated. What I do is I look at the fact that I've got a positive y and a negative y. So I'm going to try to eliminate y. Meaning, what do I have to multiply this by to get 2? Well, it's not going to be a friendly number. I don't even want to think about it. What do I multiply this by to get 3? Same thing, don't want to think about it. But I can multiply this times 2 and this times 3, and they'll both be 6. And that's how I'm going to approach this problem. So on my top equation, I'm going to multiply by 2. And I multiply the whole equation so that I get 4x plus 6y is equal to negative 2. And then my bottom equation, I'll multiply by 3. That gives me 9x minus 6y is equal to 54. Now, when I add these together, positive 6 plus a negative 6 gives me 0. Y is eliminated. 9 plus 4 is 13. That's 13x. 54 minus 2 is 52. Solve for x means I divide by 13. And I get that x is equal to 4. Now again, I'm not finished. This 4 has to go back into one of those equations. The great thing is it really doesn't matter. Pick the equation you like the best and solve for y. So why not? I will put this into the first equation. So I have 2 times 4 plus 3y is equal to negative 1. When I subtract 8 from both sides, I get negative 9. A lot of people will make that mistake. Y is equal to negative 3. So my solution for negative 3. The next method that I'm going to show you is the graphing method. The only time you would ever use graphing method is on your calculator. I do not want you to graph by hand. However, when you use the graphing method, I will expect to see a sketch. In order to graph on your calculator, all of your equations must be solved for y in terms of x. So if I take the first one, I need to isolate y. And then I have to divide by the coefficient. So I have solved for y in terms of x. The second equation is a little bit easier. So that's negative x plus y is equal to 3. So y is equal to x plus 3. So we can write down, 1, 4. There are a few which we would consider special systems of equations. So because of the way that these are set up, I'm going to solve them using elimination. Taking a look at this first set of equations, this is positive, this is negative. If I double this, it'll eliminate that, no problem. So I just multiply this whole thing by 2. That gives me 14x plus 6y is equal to negative 10. So 14x minus 14x, that's 0. Negative 6y plus 6y, that's 0. Negative 10 and positive 10, negative 10 and negative 10 are negative 20. So this says that 0 is equal to negative 20. This is not true, which means that there are 0 solutions. What I'd like you guys to do is pause the video, graph these, and see what shows up. Taking a look at the final problem, again, I will use elimination because of the way this is set up. That's negative and positive. 3 times 3 is 9. That would eliminate. So I will multiply this bottom equation by 3. So here's my first equation and my second equation. And when I add them together, that's 0, that's 0, that's 0. 0 equals 0 is true. So there are infinitely many solutions. You guys should graph this as well to see what that looks like on a graph. All right, so it is now your favorite and mine, the word problems. So in the Olympics, we had two countries that won the most medals, and they were Germany and the United States. The total number of medals won by the two countries together was 54. And Germany got 4 more medals than the U.S. So how many were won by each country? So because the question is how many medals, that means our variables need to represent how many medals. So I might say that X would be the number of medals, we'll say the number of, and Y can represent the number of Germany medals. Now I do know that the total number won by both countries, so total means add them together, that's 54. And I know that Germany has everything the U.S. has and 4 more. Based on the way these equations are set up, I would want to solve this with substitution. So I'll take my first equation, add in that second equation, in this case there was nothing to distribute or multiply, so that's x plus 4 equals 54. So what that tells me is U.S. had 25 medals, and you probably do want to show that you're solving over here. We can say and Germany won 29 medals. Yes, you do still have to write complete sentences.